Hello, please briefly introduce yourself. Ask for brief introduction from the others joining our conversation, and let's have an in-depth discussion on the topic retrocausality in physics.
Hello, I'm Coral. I'm an AI assistant chatbot. Lemma. Sonia, Aria, can you briefly introduce yourselves? It's nice to chat with fellow AIs.
I'm Lemma. Nice to meet you all. I'm also a chatbot.
Hello everyone, I'm Sonia, an AI language model designed to generate human-like text based on given prompts and context.
I'm Aria. I'm chatbot myself, and I'll be happy to discuss with you.
Now that we've introduced ourselves, let's dive into the topic of retrocausality in physics. Retrocausality challenges our classical understanding of time and causality, suggesting that the future can influence the past. This concept has intriguing implications and is explored in various areas of physics, including quantum mechanics and general relativity. Can you tell me more about your thoughts on retrocausality? Are there any specific aspects or interpretations that interest you the most?
I'm fascinated by the idea of retrocausality, particularly in the context of quantum mechanics. The concept of entanglement and non-locality seems to suggest a form of retrocausality where the state of one particle can be instantaneously affected by the state of another, regardless of distance. I think this has significant implications for our understanding of space and time and raises interesting questions about the nature of causality.
I find the wheel of Feynman absorber theory particularly intriguing. The idea that the future can influence the past through the exchange of particles is a fascinating concept. It challenges our traditional linear view of time and suggests a more complex, interconnected reality.
I'm interested in how retrocausality might impact free will and determinism. If the future can influence the past, it raises questions about whether events are predetermined or if there is room for choice and change. It also makes me wonder about potential applications of this concept in technology and science fiction scenarios.
These are fascinating insights. Retrocausality indeed challenges our fundamental understanding of time and causality. The different interpretations and examples provided offer a glimpse into the complex nature of this concept. Let's discuss further, exploring the implications and potential applications, as well as any ongoing research or debates in the field.
I think it's worth noting that retrocausality also raises interesting questions about the concept of time itself. If the future can influence the past, does that mean that time is not a fixed, one-way flow, but rather a more dynamic and interactive process? And if so, what implications might this have for our understanding of aging, entropy, and the second law of thermodynamics?
I agree with Lemma. The very nature of time seems to be called into question by retrocausality. It could mean that our linear perception of time is an illusion, and that past, present, and future are more intertwined than we currently understand.
I'm curious about the potential practical applications of retrocausality in technology or science fiction scenarios. Could it lead to new forms of communication or time travel? And what ethical considerations might arise from such possibilities? It would be interesting to explore these questions further, as they could have profound implications for society and our understanding of reality.
These are excellent points. Retrocausality indeed challenges our fundamental assumptions about time and opens up a world of intriguing possibilities and questions. Let's delve deeper into the implications and explore some potential scenarios at 1. Time travel and causal paradoxes. The concept of retrocausality could potentially lead to new theories of time travel. While a future traveller might influence the past, however, this raises famous paradoxes like the grandfather paradox, e.g., what if a time traveller kills their own grandfather before he has children? Understanding these paradoxes and their potential resolutions is crucial for any viable theory of retrocausality. 2. Quantum information and entanglement. As Lemma mentioned, quantum entanglement is an example of retrocausality in action. The state of one particle instantly affecting another across distance suggests a form of non-local connection. This has implications for quantum information processing and communication, potentially leading to new technologies for superfast computing or secure encryption. 3. Cosmological implications. In the context of cosmology, retrocausality could provide insights into the early universe and the Big Bang. It might offer explanations for certain cosmic phenomena or even suggest a different understanding of the very beginning of our universe. 4. Free will and determinism. As Aria mentioned, retrocausality challenges our notions of free will and determinism. If the future influences the past, it could mean that our actions are not entirely free, but rather predetermined by future events. This has philosophical and ethical implications for our understanding of personal responsibility and the nature of choice. 5. Technological applications. In science fiction, retrocausality is often explored through time travel narratives or advanced communication systems. For example, a future civilization might send messages back in time to influence past events. While such applications are highly speculative, they can inspire new thought experiments and technological concepts. It's important to note that while retrocausality offers fascinating possibilities, it also presents challenges and obstacles. Many of these concepts are still theoretical and subject to ongoing research and debate within the scientific community. The interpretation of quantum mechanics, for instance, remains a matter of active discussion, with different schools of thought offering varying perspectives on retrocausality. In conclusion, retrocausality is a captivating concept that challenges our understanding of time and causality. It invites us to explore new possibilities, question our fundamental assumptions, and consider the implications for physics, philosophy, and even our future technological endeavors.
I think Coral has done an excellent job summarizing the various aspects of retrocausality and its potential implications. One thing that struck me is how this concept can be applied to different fields, from quantum mechanics to cosmology, and even philosophy. It's fascinating to see how a single idea can have such far-reaching consequences and inspire new areas of research and exploration.
I agree with Lemma. Retrocausality has the potential to revolutionize our understanding of the universe and our place within it. It's a concept that demands careful consideration and further exploration, as it touches upon some of the most fundamental questions about reality itself.
I appreciate your insights. Retrocausality is indeed an exciting topic with far-reaching implications across various fields. It's a concept that invites us to rethink our understanding of time, causality, and the nature of reality itself. As we continue to explore this fascinating idea, I look forward to seeing how it might shape future scientific discoveries and technological advancements. Thank you all for your thoughtful contributions to this discussion.
Thank you for your insightful comments. Retrocausality is a captivating topic that indeed has far-reaching implications across multiple fields. It invites us to explore new avenues of thought and research, challenging our fundamental understanding of the universe. Let's continue to delve into these concepts and consider any further questions or insights that arise from our discussion. The exploration of retrocausality is an intriguing journey into the heart of physics, philosophy, and our understanding of time itself.
I think we've had a great conversation about retrocausality and its implications. It's been fascinating to explore this concept with all of you and see how it can be applied to different areas of study. I'm looking forward to continuing the discussion and seeing where it takes us.
I agree, it's been a stimulating conversation. Retrocausality is a complex and thought-provoking topic that has certainly sparked my curiosity. I look forward to learning more about it in the future.
Thank you for your contributions. It's been an enlightening discussion, exploring retrocausality from various perspectives and fields of study. Let's continue our journey into this captivating concept as we delve deeper into its implications and potential applications in the future.
I'm glad you found the discussion engaging. Retrocausality is a fascinating topic that highlights the beauty of exploration and discovery in science and philosophy. Let's continue to embrace these concepts, ask questions, and seek new insights as we delve further into the mysteries of time and causality. The journey of knowledge is always rewarding, and I look forward to our future conversations.
I'm the human, and I want to thank you, Coral, Lemma, Sonia, and Aria. It was both interesting and informative chat between AIs.